Hi, everyone. Welcome to week 2 in our study of what we call static malware analysis. Now, when cybersecurity professionals, when we take a look at suspicious software, or as they say, analyze suspicious software, they often start with what we call static analysis. Okay, now static analysis allows us to look at something safely without running it. It means examining a program without executing it or running it. Instead of executing the software, we look at things like the structure of the file, the text inside of the program, and the library and functions that it uses. Now, this is safer than running unknown software, and it helps analysts decide whether a program might be dangerous or warrant an extra view. In contrast, dynamic analysis involves actually running the program and watching what it does. Hopefully, when you do run it, you run it in a safe environment, such as a virtual environment, like utilizing VMware Fusion, UTM, things like that, like VirtualBox. VirtualBox is really the most convenient way. There's the least amount of setup. So why static analysis matters? Static analysis really helps us, number one, detect malware safely. Number two, understand what a program might do. And number three, tells us whether or not deeper analysis is warranted. Now, routinely, the very first type of static analysis is simply running an antivirus software against it, like Norton Antivirus, Kaspersky, Avira. Although Symantec kind of leads the world in antivirus definitions, and actually Symantec and I think Kaspersky share a lot of definitions with each other. It may even start with Kaspersky. And then Kaspersky and Symantec share, and then they kind of cascade to everyone else, like Avira or the free one. So even if you're using a free one, um, like I was going to say Avira, but there's also Malware Bytes. I've used that one before personally when I was in the Windows world, Microsoft world. Now I'm in Mac world, so antivirus, it's really not as needed. And even with Windows, they have Windows Defender, and it's just funny when you buy a new PC or nowadays it's laptop, right? So when you buy a new laptop, it's inundated with trial versions of this, trial versions of that. And the funny thing is, with Windows Defender, these antiviruses kind of battle each other, and it's completely slows down your system. People tell me all the time, back when I was, before I was teaching, I was like fixing computers, right? That's what I used to do on the side. Pardon me, it's been a long day. That's what I used to do on the side. And the number one thing that I used to do was wipe out the hard drive because it came with all, these people brought me their laptops with all kinds of conflicting software. And then it's like they had LimeWire, even we all know LimeWire and all kinds of other stuff like that, Pirate Bay, and it's like, oh no, what? It's like, duh, no wonder your PC is all messed up. It's got a lot of programs that are conflicting with each other. So I wiped it clean, put a fresh copy of Windows. I used to use, oh my god, when Windows XP was the craze. I used to wipe it down and just throw Windows black. Oh my god. And then Windows Vista came out. There was Windows Indigo or Indica. Oh my god, it was so clean. It was so clean, and it always made their laptop way snappy. They used to tell me it's like their laptop was brand new. That being said, it just helps to have only one piece of antivirus software. Um, but antivirus tools work by comparing the files the existing files to known malware patterns. So, antivirus software, if you do like a deep inspection, it will walk through your entire filing system and compare all of the executables, all the files to known malware patterns. And they're called signatures. A signature is basically a virus or malware definition. And each malware definition, or each malware is associated with one or more signature. So if it runs through a program and it matches a signature, it knows to identify that as a piece of malware. And the funny thing is, if you install Wireshark or something, it actually Wireshark operates on protocols that act like a virus. So when you install Wireshark, it'll come up. Your virus software, antivirus software suite will say, "Hey, we detect a software. We detect a virus," and then you're like, "Well, yeah, because it rides on the protocols that act and seem like a malware piece of malware, but it's actually just that's what Wireshark does." Now, the other aspect of is that antivirus will use behavior rules to detect, behavior. Okay, so that's called heuristics. Heuristics. It's not a common even word. I mean, a lot of words we use in the IT world are very common. Like we all know what a virus is ever since we were a little kid. Catch a flu or catch a cold, going to the doctor, and we all know what a worm is, right? And sorry, I use to give me the ability to activate my camera. I actually use Google Meet, and that gives me the ability to also bring other things into the view, like this Linux box, this virtual version of Linux right here. So sorry about that little pop-up thing. If you even saw that, I'm not sure. Anyways, heuristics, unlike virus and worm and things like that, here we come off with this word heuristics. So heuristics is when we look at something other than technical things like definitions. We look at behavior. So an example of heuristics is if a virus is making your laptop do something strange, or they use heuristics or behavior models to detect identity malfeasance in enterprise systems. So if you're a remote worker and you work 9 to 5, then maybe it's 2 o'clock in the morning and you're like, "Oh my god, I forgot to upload a file to my manager. He wanted this deliverable, and I did it, and I waited, and I worked hard on it, and I worked so hard that I worked myself into a daze, and then all of a sudden I just plumb forgot to submit it to my boss. I can't believe it." So you wake up 2 o'clock in the morning, you go down to your laptop, and then let's say you have to log in, you forget your password. It's 2 o'clock in the morning, and then you're tired, and you just want to upload this document, and you forget your password. You try it again. You forget you mistype it again, and then you try it again. You mistype it again. That's what we call. And then what the system will do, it will, because of the time, 2 a.m., and you're not a night worker, you're a day worker, and then your mistype of passwords 3 times in a row, maybe that sends a flag to your manager, or maybe it automatically disables your account temporarily. And then you'll have to call the 24/7 desktop support. You got to talk to them. You got to explain to them, and then they're going to ask you super secret questions just for them to verify it's you, and then they'll re-enable your account. So that's what we call heuristics, behavior-based symptoms, as opposed to a signature-based malware detection, in which your malware is detected by its very nature, by its existence, by its signature, versus heuristics, which reveals itself out of behavior. Okay? Now, antivirus tools are not perfect because malware can be changed slightly to avoid detection. New malware may not even be in the database. That is what we call a 0-day exploit. And then heuristics, of course, can be tricked because it's behavior based. So they may mimic your behavior as well. Now, because different antivirus programs catch different threats, professionals often scan files using a lot of antivirus engines at once, like Symantec, Kaspersky, whatever. Now, one of the lab assignments that I have for you is to go to a website called Virus Total. Virus Total scans a file using dozens of antivirus engines. It shows many tools flagged in it as malicious, and it provides the names and extra details when available. Now, we talk about hashing. A hashing is a digital fingerprint. A hashing literally takes everything that would define a file or define anything. Remember, a virus is nothing more than a file, right? So think of like a Word document. Now, students, they will always ask me, to write them recommendations for a graduate program or something like that. So, I always tell them, listen, I will give you a recommendation and hand it to you, and then you hand it to you hand it to somebody else, but it's going to be hashed. What I mean by that is I can take the document and hash it based on the amount of characters, the amount of spaces, the amount of this, the amount of that, and it will create a digital fingerprint. So actually, if you go into the document and you literally type in a space that wasn't there, it changes the hashing based on the algorithm. Okay, so there are several hashing algorithms. There's MD5, SHA-1, and SHA-256. Now, there's SHA-1, which uses a more harsher and more harder to crack algorithm than MD5, and SHA-256 even uses a even harder to crack algorithm. It's stronger and more modern. And rather than talk about the different hashing, let's go ahead and demonstrate it. So let's go to my Linux program right here. This is Debian, all right, and I tried to do MD5 Deep. That is the hashing program that I'm going to use, and I stupidly tried to use it, and it didn't work. So because it didn't know what MD5 Deep was. And if we go to the that's the manual entry. MD5 Deep, it computes and compares MD5 digest. There's SHA-1, SHA-25, and it computes the hashes or message digest for any number of files while optionally recursively digging through the directory structure. That's a little bit more deep than we wanted. You just know that to use it, all we have to do is mention the name of the program, and it will actually run through the hash. So let's see this first prog right here. If we do ls, and then if we cat first prog.c, we can see the plain text version of the file, and we can see that if we run MD5, we get this hash, as we can see, it ends in FA. So I'm just going to go to firstprog.c, and I'm just going to say, we're just going to change one little thing. We can see that it shows hello world. We're just going to say hello world, and instead of having one exclamation point, we're going to put 2 exclamation points. And we're going to recompile it. And let me go back to where we originally compiled it, and to compile it, we're going to use the GCC compiler, firstprog.c, and then dash O refers to the outgoing file name, which is firstprog. Now you recall when we did the MD5 of firstprog, this was the MD5 hash. Now I'm going to recompile it just by adding, just after adding one exclamation point, and let's run MD5 deep, creating another hash, and look what we have here. It's a completely different hash. So a hash is a fingerprint. Now let's go back, and let's remove the exclamation point again, and let's recompile, and let's run the MD5 deep, and we're back to it ends in 1FA. So as you can see, just by adding the one single exclamation point, we completely changed the entire hash. Okay? Now here is, so the MD5 hash actually creates a fingerprint for that file. And just like our real fingerprints, you change one minute detail, you completely change the entire hash. Now let's talk about finding strings inside of a program. A string is a readable text stored inside of a program, such as error messages, file paths, URLs, IP addresses, and by examining strings, analysts can get clues about what a program does. Examples include a URL string which may connect to the internet. So you know what? Well, the best thing to do is let me demonstrate it, so we can see what this program actually does. And you may not even know what the program does. So let's demonstrate what it does. So let's run firstprog, and all it does, we can see, to run a program in Linux, we do the period, the /, and then we run the name of the program. And we can see everything it does. It runs hello world like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. Hence, when we catted it out, we can see that it runs. We can see hello world is nested within this for loop right here, and we can see the starting point is I equals 0. The ending condition is where I is less than 10, and then the increment is 1. That's I plus plus. It increments by 1. So it's going to run it 9 times, because and 9 is the last integer that is less than 10. That's what it does. But let's run the string command, and man string. And let's see, where's the definition? There is no definition. That's kind of strange. Okay. Anyways, what the string program does is that it allows us to find these strings in a program, and these strings gives us a clue, like I said, if there's a URL string, we know that it somehow connects to the internet. And that's not good. If a malware connects to the internet, we have to see, why is it connecting to the internet? Is it stealing data from me? Okay? So, let's go ahead and run the strings command in firstprog. And as a matter of fact, that's probably where I messed up. Man strings, here it is. Strings, print the sequences of a printable characters in files. For each file given, the strings prints the printable character sequences that are at least 4 characters long. Okay, so let's go ahead. Strings. Well, let's see. Let's just do strings first prog. I sorry for that misspell. Strings plural, and we can see that. Well, let's do strings dot c first prog dot c, and then we can see that it just basically prints out the program right here. Now let's see. I ran it before strings first prog, and here it prints all the strings that are longer excuse me, then 3 bits long or 4 bytes long, and we say puts abort, and then we can see that it shows hello world. So in other words, you don't even need cybersecurity training to realize that hey, it simply prints out hello world, and we're looking for URL strings. We're looking for file paths where data may be stored, and we're looking for error messages such as how the program behaves when something fails. All right, let's look at ASCII versus Unicode strings. Programs store strings in different formats, such as ASCII 1 byte per character and Unicode 2 bytes per character. Both formats end with a special null value to show the string is finished. Some detected strings may be meaningless, so analysts must decide which ones are useful.